Welcome to the deep dive. Today you're getting into something pretty fundamental in modern software, how we actually build and test the stuff.
That's right.
If you've ever looked at some teams and thought, how do they push updates constantly without everything just, falling apart?
Yeah.
Then you are definitely in the right place.
Absolutely. We're looking at this document, DevOps and software testing the perfect match for faster, better quality. And really the goal is to unpack how this whole DevOps thing, this merging of development and operations, is just completely changing the game for software quality.
Right. Forget the old way of doing things.
Exactly. Forget those silos. This is all about integration right from the very beginning.
Okay. So our mission today is pretty clear. Cut through the buzzwords, give you a really solid grasp of these changes, and show how it all leads to, faster and better software.
Couldn't have said it better.
All right, let's dive in. At its heart, what is DevOps really?
Well, fundamentally, DevOps is it's a mix of culture, practices, and tools. It brings software development, dev, and IT operations ops together.
Okay.
And the main goal, speed up that whole software lifecycle from idea to production while also making the final product, higher quality. It's about tearing down those traditional walls.
The walls between the coders and the people who actually run the software.
Precisely. The ones who code it and the ones who deploy it and keep it running.
So it's definitely not just about buying some new software, is it? It sounds deeper than that.
Oh, absolutely. Tools are important. They enable it, but DevOps is really driven by core principles and a shift in culture. This document we're using highlights 4 key ones. First up, collaboration.
Yeah.
And this isn't just like being nice to each other. It means dev and ops teams working super closely, understanding each other's worlds, their challenges, their goals, all the way through.
Yeah, that makes sense. Less throwing things over the wall, hoping for the best.
Exactly that. No more over the fence.
So what's number 2?
Second principle, automation. This is huge. It's all about automating those repetitive manual tasks whenever you possibly can.
Why automate?
Well, the benefits are pretty clear. You get faster results, you reduce the chance of human error, which happens, right? And you free up people to work on more complex, more valuable problems.
Right. Let the machines do the grunt work. Automation seems like the powerhouse behind the speed aspect. And number 3?
Number 3 is actually a pair. Continuous integration and continuous delivery. You'll hear it called CI/CD all the time.
CI/CD.
Got it. Yeah. Think of it like this. Developers are constantly merging their code changes into one shared central place. That's the CI part, continuous integration.
Okay. Frequent merging.
Right. Then continuous delivery, the CD part, is about automating the process of getting that integrated code ready and deployed out to users, or at least to a production-like environment. It means smaller, more frequent updates instead of massive, risky releases.
Like a constant trickle of improvements instead of a huge flood once or twice a year.
Exactly. A steady stream of value.
Makes sense. Integrate often, deploy often. What's the final piece of the puzzle?
The last one is monitoring and feedback. So once the software is live, you're constantly watching it. How's it performing? Is it stable? How are users actually interacting with it?
So you're keeping an eye on it in the wild.
Constantly.
Yeah.
And the key is to spot any problems, any glitches, really quickly, and feed that information straight back to the development team so they can fix it fast. It closes the loop.
Okay, so those 4 pillars, collaboration, automation, CI/CD, and monitoring, really define DevOps.
Yeah.
Now, how does this completely different way of working change something like software testing? Because, traditionally testing was always that final hurdle, right? The gatekeeper.
That's exactly right. In the old model, testing was often the separate phase tacked on at the very end. Sometimes it felt like an afterthought, honestly.
Yeah, I've seen that.
But DevOps flips that script. The document really emphasizes this. Testing isn't at the end anymore. It's integrated early, and it happens continuously throughout the entire life cycle. It's a fundamental shift.
Okay, so testing moves from being a gate to being, part of the entire road.
That's a great way to put it. And this leads us straight into a core concept in DevOps testing. Continuous testing.
Continuous testing. So not just testing once at the end?
Nope. It means running automated tests pretty much constantly at various points in the development pipeline.
So like every time a developer commits some code,
right,
bang, tests run.
Basically, yes. As soon as code changes, automated tests kick off. And the real magic here is the immediate feedback. If a change breaks something, the developer finds out almost instantly. They can fix it right then and there while it's all fresh in their mind. Think how much more efficient that is.
Be massively more efficient than finding a bug weeks later during some big stressful testing phase.
Exactly.
Can you give me a sort of practical example of that continuous testing loop?
Sure. Let's go back to that CI/CD pipeline idea, that software factory. A developer finishes a piece of code, they commit it to the shared repository, the central blueprint. The CI system immediately picks that up and starts running tests, often starting with unit tests. These check the smallest bits of code in isolation.
Before it even gets mixed in with everything else.
Yeah, it's like having tiny quality checks happening automatically all the time at the very first stage.
Okay, got it. Catch the small stuff super early. Now, the document also mentions shift-left testing. What's that about? Sounds related.
It is related, and it's another really crucial idea. So, if traditional testing happened late on the right side of the timeline,
Yeah.
shift left means deliberately moving testing activities much earlier to the left side of that timeline. Ideally, starting almost as soon as code starts being written, maybe even during planning.
Whoa. Okay. So testers aren't just waiting at the end anymore. They're involved from day one.
Pretty much. Testers become collaborators right from the start. They help define what needs to be tested. They look at requirements. They might even weigh in on design to make sure the software can be tested effectively.
That's a big change in role.
It is. And just like continuous testing, different kinds of tests, especially unit tests and integration tests, get written early on and run all the time as the code evolves.
Can you give an example of shift left? How does that actually look?
Okay, imagine a developer starting work on a new feature. In a shift-left world, maybe they sit down with a tester first to really nail down the acceptance criteria. How do we know this feature works correctly? Make them testable.
Before coding.
Before coding or right alongside the first bits in code. The developer might even write some basic unit tests themselves as they go. Then those tests become part of the automated pipeline, running constantly, catching issues super early. It's about embedding quality right from the foundation.
Okay, I think I see the distinction. Continuous testing is about the frequency testing all the time.
Yeah.
Shift left is about the timing, starting testing way earlier.
You got it.
What makes both of these things actually possible? Because it sounds like a lot of testing. The document really hammers on automation.
Yeah, you absolutely nailed it. Automation testing is the engine. It's what makes continuous testing and shift left practical, especially at scale.
You just couldn't do it manually.
No way! Think about it. Testing constantly, testing super early. If you relied only on humans clicking through screens, you'd grind to a halt. Or you'd need an army of testers. Automation is key for speed and repeatability.
So the tester's job changes quite a bit then. It becomes more about building the automation.
Definitely. In a DevOps setup, testers spend a lot more time designing, writing, and maintaining automated test scripts that plug right into that CI/CD pipeline.
Right.
This lets tests run fast, run often, without needing someone to manually trigger them every single time. And we're talking automation at different levels, testing the user interface, the APIs, performance, security.
The document threw out some names. Selenium, Cypress for UI, Unit for unit tests, Postman for APIs.
Yeah.
Are those typical tools?
Yeah, those are very common examples. Selenium and Cypress are big in UI testing. JUnit is a standard for Java unit tests. Postman is popular for testing APIs. They're representative of the kind of tools testers increasingly need to be comfortable with.
So technical skills become more important for testers in this world.
For sure. Using these tools effectively to build reliable, useful, automated tests is a core skill. Tests that give you that quick, trustworthy feedback loop.
Okay, this is starting to paint a really clear picture. We've got the DevOps principles. We see how testing shifts left and becomes continuous, all powered by automation. Now, the big question, why does this matter? What are the real payoffs for doing things this way?
Oh, the benefits are significant. Let's start with the obvious one. Faster time to market.
Getting software out the door quicker.
Exactly. Because so much of the pipeline, including testing, is automated with CI/CD, you can validate code changes and get them into production much, much faster. It's about reducing that lead time from idea to user.
So that gap between a developer finishing some code and a user actually getting to use that feature shrinks dramatically.
Precisely. Continuous testing removes that massive bottleneck you used to have at the end. Testing just becomes part of the daily flow,
Right.
which speeds things up, makes collaboration smoother, removes delays, and, crucially, the speed doesn't mean you sacrifice quality. Those fast feedback loops actually reinforce quality along the way.
Can you give an example?
Yeah, think about, say, a new feature on an online store. With a solid DevOps pipeline, that feature could potentially go from concept to coded, tested, and live for customers in maybe hours or a day.
Instead of weeks or months.
Exactly. That's a huge competitive advantage right there, being able to respond quickly.
Okay, faster delivery, faster feedback. That's compelling. What else?
Another major benefit is enhanced team collaboration. We touched on this, but DevOps really works to break down those old silos. Dev, test, they're not separate kingdoms anymore.
They have to work together.
They have to. And testers, specifically, get pulled in much earlier. They're not just receiving code at the end, they're part of a unified team, all aiming for the same goal: fast, high-quality delivery.
So testers have more influence earlier on.
Absolutely. They're in requirements discussions. They help define what done means in a testable way. They might even suggest design changes to make testing easier later. It just leads to better communication, better alignment.
How does that play out day to day?
You might see developers and testers in the same daily stand-up meeting, talking about issues, deciding which tests are priorities. It's much more fluid, much more efficient than formal handoffs and bug reports flying back and forth days later.
Right. Everyone's pulling in the same direction right from the start.
Right.
Makes sense. And what's the third key benefit?
The third big one is elevated quality through early bug detection. This builds on the other points.
Okay.
If you're testing constantly, starting early, you're just going to find bugs sooner. Simple as that.
Before they get baked in and harder to fix.
Exactly. Before they become deeply tangled in the code, making them more expensive and time-consuming to sort out. It's like finding that tiny crack in the wall before it becomes a major structural problem.
Yeah.
Testers can quickly spot regressions when new code accidentally breaks something that used to work. Those automated tests act like a safety net, constantly checking that things are still okay.
Can you give an example of that early detection?
Sure. Imagine a performance test that runs automatically with every build. Maybe it flags that a recent code change suddenly made the website checkout process 10% slower.
Oh.
The team sees that immediately before any customers experience that slowdown, and they can fix it proactively. That's the power of catching things early.
Okay, so faster releases, better teamwork, higher quality baked in. It sounds fantastic. Almost too good to be true. What are the catches? What challenges do teams actually face when they try to implement all this?
That's a fair question. It's definitely not always a smooth ride. One common challenge is tool integration.
Getting all the software to play nicely together?
Exactly. Your CI/CD pipeline might involve, Git for version control, Jenkins for building, Docker for containers, maybe Kubernetes for deployment. A whole stack of tools.
Right.
Getting your test automation tools like Selenium or whatever you choose to integrate seamlessly with all of that can be tricky. Making sure tests trigger correctly, results get reported back properly, it can require some real technical effort.
So it's not always just plug and play. You might need custom setups.
Often, yeah. You might need specific configurations, maybe some custom scripts, just to glue everything together effectively. It takes expertise.
Okay, tool wrangling. That sounds like a potential headache. What's another hurdle?
Another big one is bridging the skills gap. We talked about how the tester role evolves.
Right, needing more automation skills.
Exactly. Testers who come from a more traditional manual testing background might not have the programming skills or the deep understanding of automation frameworks needed for DevOps. It requires learning new things.
So people need to upskill.
Absolutely. Organizations really need to invest in training, teaching testers about the specific DevOps tools being used, about automation best practices, maybe even basic scripting in languages like Python or JavaScript.
So it's an investment in your people.
It has to be. You need to empower testers to become effective contributors in this automated environment.
Makes sense. People and tools. What's one more common challenge?
The last one the document highlights is a real pain point. Tackling flaky tests.
Flaky tests, what are those?
These are tests that sometimes pass, sometimes fail, even when the underlying application code hasn't changed at all.
Oh, that sounds infuriating.
It is. They're incredibly disruptive. If a test fails intermittently, maybe because of a brief network glitch or some timing issue in the UI, it can stop the whole CI/CD pipeline. Worse, it erodes trust. If tests fail randomly, people might start ignoring all failures, including the real ones.
Right, the cry wolf effect. How do you deal with that?
It requires real diligence. Good test design from the start, careful maintenance. You have to investigate why a test is flaky. Dig into the root cause. Is it waiting properly for elements to load? Is there an unstable environment?
So finding the cause and fixing the test itself.
Exactly. Or implementing strategies like adding intelligent waits, maybe automatically retrying a failed step once or twice, anything to make the tests more stable and reliable. because unreliable tests undermine the whole point of automation.
Okay, wow. We've really covered a lot. We've seen how DevOps changes the whole landscape for testing, making it continuous, shifting it left, relying heavily on automation.
Yeah.
We've talked about the big win: speed, collaboration, quality, and also some very real challenges like tools, skills, and those flaky tests.
Yeah, it's quite a transformation.
So if someone listening wants to boil this all down, what are the absolute key takeaways, the core message?
I'd say the main thing is DevOps isn't just tweaking testing, it redefines it. It moves from being a separate phase at the end to being this continuous integrated activity.
Built in, not bolted on.
Exactly. It's woven into the entire life cycle using automation, CI/CD, and crucially, that deep collaboration between dev, tests, and ops.
So being proactive about quality from the start, not just reactive at the end.
Precisely. You use continuous testing, you use shift-left thinking, you build those automated test suites, and the result is less testing effort overall, but much higher quality and reliability in the software you deliver.
And it sounds like the people side, that collaborative culture, is just as vital as any tool.
Oh, completely. The document really stresses this. A successful move to DevOps testing depends heavily on fostering that culture where everyone feels shared ownership for both speed and quality. Breaking down those silos is paramount.
This has been incredibly illuminating, a real deep dive into how modern software gets built and assured. So for everyone listening, trying to stay informed, what's a final thought we can leave them with? Something to chew on.
Okay, here's something to consider. Looking at your own world, whether you're in development or testing or operations, what's one small step you could take toward these ideas? Maybe it's automating just one repetitive test case. Maybe it's initiating one conversation between a developer and a tester earlier in the process than usual. Think about that first small step, because sometimes that initial focused effort can be the start of a really significant improvement in how you build and deliver software.